Welcome to Study Loop.
So in this problem, first we will find out the original number of moles of the aqueous solution of hydrogen bromide HBr, and then we will find out the number of moles of sodium hydroxide its uh, it- from its concentration and the volume which is needed to reach the equivalence point. And from the number of moles of sodium hydroxide, we'll be able to say that how many moles of HBr um, was titrated by sodium hydroxide, and from that number of moles of HBr, we will be able to find out the number of moles of HBr which was titrated by the zinc hydroxide, and from there we can find out the number of moles of the zinc hydroxide which is added here, and from the number of moles of zinc hydroxide, we can find the mass of zinc hydroxide here. So first step is finding the number of mole of HBr original solution, which we can find out from the molarity and the volume of this HBr solution. So the molarity of this HBr is given as 0.500 molar or mole per liter times the volume, which is 0.350 liter, and it will give us a value of 0.175 mole. So this is the number of mole of HBr. Now we have to find out the number of moles of sodium hydroxide which um, which has titrated the remaining amount of HBr after the addition of zinc hydroxide. So the number of mole of sodium hydroxide here is again the concentration or the molarity of sodium hydroxide, which is again 0.500 mole per liter times the volume which is required, 88.5 milliliter. We have to write it in liters, so 88.5 times 10 to the power minus 3 liter, and this will give us a value of 0.044 mole. So this is the number of mole of sodium hydroxide which has titrated the remaining amount of HBr. Now we have to set up a balanced equation for the titration of HBr by sodium hydroxide. So it will be a 1:1 reaction since we have one proton in HBr, and that means from the reaction you can see, so since it's a balanced equation already, so from here you can see that 1 mole of HBr reacts with 1 mole of sodium hydroxide. That means um, this much mole of sodium hydroxide will react with the same number of mole of HBr. That means we can write down now that um, the number of mole of HBr which is titrated by sodium hydroxide will be equal to the same as the number of mole of sodium hydroxide, which is 0.044 mole. Now we have to find out the number of mole of HBr which was titrated by the zinc hydroxide. So number of mole of HBr titrated by zinc hydroxide will be equal to the original number of mole of HBr, which is 0.175 mole, minus the number of mole of HBr titrated by sodium hydroxide, which is 0.044 mole, and this will give us a value of 0.131 mole. So this is the number of mole of HBr which is titrated by zinc hydroxide. So from this number of mole of HBr, using the balanced equation with zinc hydroxide, we can find the number of mole of zinc hydroxide which is added. So the balanced equation will be HBr plus ZnOH2 will react to give us ZnBr2 plus H2O. So if you want to balance it, you have to put a 2 here, and yes, the rest is balanced. So that means um now we can find out that 2 mole HBr reacts with 1 mole of zinc hydroxide. That means this much mole of HBr, 0.131 mole HBr, will react with 1 over 2 times 0.131 mole, and which is eventually give us value of 0.065 mole of zinc hydroxide. So this is the number of mole of zinc hydroxide which is added to the solution and which is used to for the titration of the HBr. So from this number of moles of zinc hydroxide, we can find the mass of zinc hydroxide. So the mass of zinc hydroxide will be equal to, so as you know that the number of moles equal to mass over molar mass, that means mass will be um, number of moles times the molar mass. So the number of moles we have just calculated as 0.065 mole times the molar mass of zinc hydroxide. If we calculate that, we will find 99.42 gram per mole, and it will give us a value of 6.51 gram of zinc hydroxide. So this is the mass of zinc hydroxide we just added to the solution.